Okay, in this next video, we are going to solve some problems involving the Ohm's law and the formulas for electric power. Calculate how much current, so we are looking for I, warms your feet with electric socks that have a 90 ohm heating element. So 90 ohm, that's my resistance, powered by a 9-volt battery. So that's my power source, that's my voltage. Okay, so I guess we can use the basic formula for the Ohm's law. Current is equal to voltage divided by resistance. I is equal to V over R. V is 9 and resistance is 90 ohms. So that's 9 over 90. You should get a current of zero point 0.1 amperes. Okay, so this is the same setup. We have a flashlight. We have voltage here of 3 volts and resistance of 60 ohms. What's the current in amperes? We will use the same formula. That's going to be 3 over 60. I is equal to 0.05 amperes. Third one, we have an electrical device with a resistance of 3 ohms and allow the current of 4 amperes. Okay, so this time we're looking for the voltage that is lost across the device. So we're given with resistance and current. So we just need to flip things around. In our original formula, we should put R together with I over there. So it's going to be V is equal to I times R. So we get the product of 3 and 4. That's going to be 12 volts. Okay, in the fourth one, now we are calculating for the power. Remember, we have 3 formulas for power that operates on 120 volts. We're given with volts and current. So this is easy. Power is current times voltage. That's just 120 times 10. 1,200 watts or 1.2 kilowatts if you divide by 1,000. Okay, number 5. We have a lamp rated at 120 watts. That's my power here. Operates on a 240 volt line. How much current does it draw? Okay, so this time we're looking for current. We have power and voltage as the given. Okay, this is my formula. Looking for I, so I suppose we have to divide both sides by V. P over V, power over voltage, 120 watts over 240 volts. That's going to give you an ampere of 0.5 amperes. Number 6. Oh, okay, so we have a table here going back to Ohm's law to complete the table. Okay, first row, our formula, by the way. First row, what is missing is current. So we will use this formula, V over R. So it's going to be 1.5 over 3. Second and third row, what's missing is voltage. So we're using the second formula. So that's we have to get the product of 3 and 1.5 and 6 and 0.25. Formula for resistance, V over I. So 3 divide 0.5 and 4.5 divide 0.75. So these are the 3 formulas in Ohm's law. Same thing, just different um, configurations. Your answers should be this way. Calculate the resistance and the current. So we are calculating for 2 things here. Of a 7.5 watt night light bulb plugged into a household outlet of 120 volts. So we're given with power and current, and we need to calculate for 2 things, resistance and current. So let's calculate for current first, because that's already in the formula for power. So P is equal to I times V. We divide again both sides by V, and we are able to come up with this formula. So that's going to be 7.5 divided 120. The answer is going to be current of 0.0625 amperes. So now let's calculate for resistance. Now resistance is not here on the original power equation. But then again, remember that we can substitute the Ohm's law in this equation. So remember that voltage is equivalent to I times R. There's R, what we are looking for. We put I times R here on this one. So we now have two I's, I squared times R. And then divide both sides by R squared to get an equation for R. This is our formula, P over I squared. So that's going to be 7.5 watts divided by our current of 0.0625. Let's square that, and we have a resistance of 1920 ohms. Okay, so here we have a current of 15 amperes. And again, we need to find two things, resistance and power. The saw is connected to an outlet of 120 volts. Okay, so power first. We have current and voltage, so we are just going to multiply that. 1800 watts or 1.8 kilowatts. Now let's calculate for resistance. We already derived the equation from a while ago, right? Mm, oh, it's different. Mm, but I guess we can also use the last equation. I guess the value of this is showing you the other formula for power. Power is equal to voltage square over R. We shift things around, so we get the formula for R. So that's going to be 120 volts square divided by 1800 watts. Always use the watts unit here, not the kilowatts. Okay, so if we do the math, 120 squared divided by 1800, that's going to be 8 ohms. You can also try the previous formula for power. P is equal to I squared times R, right? Because resistance is also present in that. And at the same time, you're also given with current here. So that should also work. Okay, I think in here, I don't have any solution. This is, I guess, would serve as your assignment. You are given with current 1.99 amps and voltage of 120 volts. I suppose computing for power is easy. And remember, computing for resistance, you have two options. Good luck.